In today's lesson, we're going to be talking about angles, basically how we name them, how we classify them, and some different parts of the angle. All right, so the first thing we're going to talk about is what we call a ray. So a ray is part of a line. It has one end point and one end that goes on forever. Now, this is what we use to create an angle. We have two rays that connect together at their endpoints to form an angle. Now, when we name a ray, we start with the endpoint. So here we'd have P. The second letter is one of the other letters on that line. So I'm going to use S because it's closest to the arrow. And then we draw what looks like a ray on top of it. So a line with an arrow on one end. This is how we would name a ray. So again, a ray has one end that has an endpoint and the other has an arrow. Opposite rays are when we have a straight line. So opposite rays are a straight line, and we could have two rays, they're going in opposite directions. So if B is the endpoint of our ray, we have two different rays here. So we could say we have BA is one ray and BC is another one. Since they're on a straight line, again, they're called opposite rays, and that means that points A, B, and C are collinear, meaning they're all on the same line together. So as I said previously, an angle is formed by two rays. Now they are non-collinear, meaning that they have where the endpoints meet are not on the same line. All right, so it's not collinear. We have that bend that makes it look like an angle. So the rays are called the sides of the angle. And the common endpoint is the vertex. All right, so this would be our vertex, and this would be one of the rays, and this would be the other ray, and these are both the sides. Now, when we name an angle, there's two different ways we can name this, but the most specific way we can name it is using three letters. The vertex must be the second letter. Now, if I'm looking at, I'm going to highlight an angle here. Let's say I'm looking at this angle here. So I'm going to name that angle LJN. Now notice I have the angle symbol out front of it. You must have that. J is the vertex. It's the middle of the angle, and that's the middle letter. Now there are ways and cases in which we can name an angle with one letter. So I couldn't name in this case just angle J because I wouldn't know which angle we're talking about. There are so many angles that have a vertex of J that there would be no way to conclude which angle we were referring to. So that's why we can use three letters. Now, I could have written this as well as NJL. Okay, so I could have gone in this order. The most important thing, again, is that J is the middle letter. That's the vertex. So we use these names to think of them as like a road map. It allows us to kind of track where we're going to see which angle we're talking about. So if I had angle LJN, I'd start at L, go to J, go to N. That would tell me that this is the angle I was talking about. Now, if we have an angle on a plane, this will divide the plane into interior and exterior parts. If we think about our angle here, and we think about closing this together, so bringing those two sides close together so that they were on top of each other, everything that would be trapped inside is the interior of the angle. So, for example, points S and R are on the interior of this angle. Then on the other side of this, that's the exterior. So points P and O are on the exterior of the angle. Points Q, M, and N are on the angle. So we could use these to name the angle. Now I could name this angle angle QMN, or angle NMQ. So we just need to make sure M is in the middle because that's our vertex. So this is made up of two rays, and I'm just going to show you again how we'd write that. So M and Q make one ray, and M and N make another ray. And again, the rays are the sides. We always want to start with the end point. So when we're looking at an angle, that's the vertex. So next we're going to talk about what we call an angle bisector. So that cuts an angle in half. So if we have angle XYZ, we see that ray YW cuts this angle in half. So that means that angle XYW is equal to 80 degrees, and angle ZYW is equal to 80 degrees. Now again, this is an important place that we are using those three letters to name our angle. If we just name angle Y, there are three different angles we could be talking about here. We could be talking about this angle, that has a vertex at Y. We could be talking about this angle, that has a vertex at Y. Or we could be talking about the whole angle, that also has a vertex at Y. So that's why it's really important that we're using three letters to name our angles so that we can differentiate between them. All right, so we're going to look at this diagram here, and the first thing we're asked to do is name all of the angles that have B as a vertex. So I'm going to locate B, and I see that's this point right here. So I'm going to name the angles that have B as the vertex. So I have angle GBA, that's an angle. I also see that I have this angle here, GBE, or GBF, that's another way we can name it. Or, I'm going to write this up here, GBE, that's also equal to angle 5. So see how we have that 5 notated in the angle space? That's just a shorthand way to name this. You'll see that a lot in like the homework and different diagrams when there are many angles. It's just an easy way to refer to them. We also have angle EBD. And we could call that angle 6. And also DBA, which could also in this diagram be referred to as angle 7. All right, so now we're asked to name the sides of angle 5. So I'm going to locate angle 5, and I'm going to highlight that. All right, so this is angle 5, so I want to locate the vertex, and that's going to tell me my starting point for each of these rays. So remember, the sides of an angle are made up of rays. So I know that BG is one of my sides, right here. And I also have BE or BF. It does not matter which letter you use, E or F. Just make sure that B is the vertex. I'm going to use F just to be different. All right, and then lastly, it says write another name for angle 6. Well, we already did that up here. So we could call it angle EBD. We could also call this angle FBD. All right, we could use this point, FBD. It's still talking about the same angle. It's just another point on that ray. You could also switch the letters around. So you have angle DBE or angle DBF. Again, making sure that your vertex is the middle letter in each of these angle names. All right, and then lastly, we're going to talk about just certain classifications of angles. So angles are measured in units called degrees. A right angle is 90 degrees. An angle less than 90 is acute. And an angle greater than 90 is obtuse. So when we're talking about these angles here, so we're just going to kind of use the the different landmarks that we have to kind of help us figure out. I'm not going to ask you to use a protractor. We're just going to kind of eyeball it to see what kind of angle we have. So again, looking at your angle name, that's a road map. So you're going to follow from T to Y to V. All right, so now this I see is going to be a right angle because I see that this is a straight line, opposite rays. Now on a straight line, we have 180 degrees. So that means if this is 90 degrees, the other part has to be 90 degrees. So that means we have a right angle there. All right, my next angle here, angle W to Y to T. All right, well, if this part is 90 degrees, I see that this is greater than that, so that means I'm going to have an obtuse angle. All right, and lastly, we have angle TYU, and I see that is smaller than my 90-degree angle, so that's acute.